Hi everyone, this is ARTTech Seminar 2022 edition. A word to those who watch the presentations over stream. If you want to ask questions, you should go to Discord, Assembly Discord server. There is discussions and seminar. And yeah, if you have questions, for example, to Timo, I'll try to grab the questions and present at the end of the talk. But yeah, I'm privileged to have Timo here. I believe it's his third time at the ARTTech stage. So focusing on graphics rendering, he has been, if you're curious to learn about his history on the topic of rendering, please visit the older ARTTech seminar speeches. But yeah, this time he has been working for the past 2 years to modernize the Supercell rendering systems. Yeah, take it away, Timo.
Thanks. So, hi everyone, and welcome to this presentation. Haven't really been talking at any stage for a while now, so it's exciting for me as well. So, as already mentioned, I'm going to be talking about modernizing our rendering pipelines at Supercell. As a quick agenda, I'm first going to do like a quick overview of the history of rendering at Supercell and how we got here, and some like reasoning for why we actually started rewriting our rendering. Then I'm going to be talking about the process of actually rewriting the renderer and some details also about like how it works and stuff like that. And then finally, I'm going to be going into a bit more detail, like a bit more learnings of like what we gathered during the development process, and maybe some of them will be useful for you guys as well. So for those of you who don't know, Supercell was founded in 2010, and we're known for games such as Hay Day, Clash of Clans, Boom Beach, Clash Royale, and Brawl Stars. Myself, as mentioned, the name is Timo Heinäpurola. I've been a Supercellian since March 2020, and I've been focusing on building our rendering capabilities since joining. So let's talk a bit about the history of rendering and how we got here. So our first game, Gunshine.net, was made in Flash. Back in the days, that was a very natural way to do things because of the platforms. So a lot of the platforms supported it, and we wanted to have like a wide support platforms. But then we decided that Gunshine.net wasn't really going anywhere, or it wasn't becoming this like huge hit that we wanted it to be. So we ended up killing it, and we pivoted to mobile, specifically tablet-oriented mobile. And we needed something native to run on iOS and Android. But we also had a history of working on Flash, and it would be natural for us to continue using Flash for content authoring, but we would need something native to actually run it on. So enter the age of Titan. So we built a pipeline for converting Flash content into our in-house formats, and this was then rendered, this content was rendered using a system called Stage, which we developed. And Stage is actually part of Titan, but Titan isn't just like for rendering. It's actually, it's actually a platform that contains a lot of functionality, like for instance, networking and push notifications and all kinds of like common platform-specific technology. And it's maintained primarily by the tools and technology team that I'm also part of. Basically, all the teams actually have the capability of like modifying Titan. They can add to it and they can modify it for sure. But the tools and technology team is kind of the team that that is responsible for maintaining it for all the different game teams. We also saw a growing need for 3D. Previously, our games have been like isometric, and they have had like these pre-rendered 3D elements incorporated in them, but nothing was really like 3D. If you look at Hay Day, for instance, the buildings are like, they look like 3D, but they're actually like just sprites, pre-rendered sprites. But with Brawl Stars, we realized that it actually makes sense to incorporate 3D elements in the game, and they actually add to the game. So that's why we started doing more of that. Originally, 3D rendering was also kind of, in a bit of a way, hacked into the stage system. Because stage plays such a core part in how we visualize everything in our games, it made sense back in the days. And then new winds started blowing for rendering. And one of the things that happened was that Apple decided to drop a bomb, which was to deprecate OpenGL ES support in iOS 12. This was a bit of a challenge for us because all of our rendering was basically developed on top of OpenGL ES directly. But we saw this as an opportunity to future-proof our rendering core. Our legacy rendering path made it a bit more complicated to incorporate these 3D elements. It was pretty hard to maintain a cohesive render state when you had like all the different systems changing individual bits and pieces of the OpenGL state machine, and you had things leaking all over the place. So we needed a rendering API that would hide the details of these individual platform APIs so that the engineers would be able to focus on the rendering logic instead of actually thinking too much about the details of those individual platform APIs. And of course, this way we would allow multiple APIs to be supported as well. So enter THOR, the god of thunder. THOR is this internal API. So it abstracts APIs such as Metal, OpenGL, and Vulkan. The name THOR is actually Titan Hardware Optimized Renderer. So it's just a kind of a wordplay to get something to remember. When I joined, we already had like a skeleton of what was to become THOR. So there was already this decision to make this kind of platform. It had support for backends for OpenGL and Metal, but it lacked many of the core concepts such as uniform buffers and stuff. So during the spring of 2020, THOR was worked in pretty much isolation. So we had like a test project that had these test cases for like buffers, textures, and very simple rendering algorithms that were just used to develop the API. Right before summer holidays, then I finally got Heyday running on THOR in a limited manner. So it was like rendering, and you could play it, but it had some bugs here and there. But it was already a good sign that this is actually going to be something. So the reason why we had decided to target Heyday initially was because everything is pretty much done using Stage in that game. So it's very limited in terms of rendering capabilities. So we could really focus on just getting Stage working and get like one simple game. Heyday isn't really simple, but like from a rendering point of view, a simple game ported so that we could test drive the system in production to make sure that everything works before we start porting all the other games and start working on the more complex feature sets required by the other games. So after getting back from summer holidays, I focused on improving and stabilizing THOR and adding all the kind of small missing bits and pieces and making sure that the memory usage isn't going through the roof or that there's some really bad performance on some specific devices and stuff like that. Basically cleaning up and making sure that everything's fine. And it was really easy to actually work with the game team. Everyone was really helpful, and whenever there was something that I needed to ask, that I need these kinds of build machines or automated testing for this feature and stuff like that, then there was always like someone to help me out. And Heyday on THOR then went live in end of 2020 and became the first game to actually use the new renderer. Currently, the games that use THOR are Heyday, Clash of Clans, Clash Royale, Brawl Stars, and Boom Beach is under construction. So we're in pretty good shape getting all the games running on that. But that was just the beginning. So after these games, the development of Thor has continued nonstop. The first major learning from the process really was that QA is your friend. So we really need to respect those guys. They allow me to sleep my nights in relative comfort, and they're a very, very important team, and they don't just get a lot of the attention that they should actually be getting. Also, the company culture played a really important role here, and it's been crucial for the development of Thor and the adoption of Thor in our games. And I'm going to be talking more about that later in the presentation. But now let's mention a couple of things about how Thor works and what it actually is. So Thor, in a nutshell, it is architectured around metal. So it takes like the core concepts of metal and runs with them. So the metal implementation of Thor is actually the most straightforward. It's not one-to-one, but it's straightforward. In addition to metal, we have backends for OpenGL, OpenGL ES, and Vulkan. Because most of the development happens on desktop computers, we also support desktop OpenGL. Vulkan is something that we don't use in production yet, but it's feature complete already. So it's just that we have so much other stuff to do as well that we haven't really gotten to that yet. Thor is also built to be multi-threaded. So we're finally able to utilize the multiple cores of modern GPUs for rendering as well. We've been doing a lot of multi-threaded code, of course, for games already, but for rendering it's been more limited because of the dependency on OpenGL and the kind of single-threaded context approach there. There were a number of design challenges related to developing Thor. First of all, we basically had to support all of the different devices that the legacy path also supported. We didn't want to drop the support for these devices just because we're working on something that the player will probably not experience in a clear way. The game might be consuming less energy, it might have a better frame rate here and there, but it's not something that players will actually experience in a clear way. So it would have not been a good idea to actually start dropping devices at this point. So this was a very important thing to consider. This did mean that we needed to support OpenGL ES too, while still allowing supporting the more powerful features of the modern APIs as well. So we needed to strike a good balance on here. Thor also needed to coexist with the legacy path to allow gradually moving games over. So we didn't want to move all our games over to Thor in one go, basically putting all our eggs in one basket. That would have just been too risky and too much work. So we ended up basically making so that these games, like all the games that are not using Thor, can continue development, and we're moving games over one by one. And also this allowed us to focus on testing of each individual game and not having to shuttle around between different projects all the time. Thor implements a relatively thin level of the rendering API. It does buffers, textures, different rendering states and shaders and stuff like that in a transparent manner. And all rendering commands are scheduled using command buffers and queues for execution. Basically, this matches pretty much what Metal does and what Vulkan does as well. But the difference really is that OpenGL doesn't have this. So we actually needed to implement this in Thor. So what we do is that we have this kind of software, or in Thor we have this host memory command buffer where we encode our draw calls. And then we send this onto the worker thread, which actually executes the GL code associated with those draw calls, and different kinds of operations that we're doing in the queue there. And this also allows us to do multi-threaded rendering in the same way that we would actually do with the other APIs as well. THOR is very extendable. Naturally, not all of the features are available on all platforms. Games can basically use the interface to check which features are supported and which features are not supported before using them. And some functionality is emulated because we didn't want to limit the API just because some specific API didn't really, or platform API didn't support a certain functionality. So we wanted to emulate some of these features to make sure that we could prepare the API for the future use cases that we might have. One of the examples is uniform buffers. OpenGL ES2 doesn't really have it out of the box, so we couldn't rely on that. And what we did basically is that we have a uniform buffer implementation in THOR that stores the values just in host memory, and then we use GL uniform calls to set those uniform values when we're rendering. But on GL ES3, Metal, and Vulkan, we actually use uniform buffers, like native uniform buffers. Our shaders are authored in GLSL, and they are first converted into SPIRV, and finally into the target language, either at load time or at game build time. So basically, we have two options there. The only problem with the load time is really that the process of taking SPIRV, generating GLSL or MSL or whatever from that is relatively expensive. So that basically adds to the load time. So we also implemented this other pipeline where we can pre-build all of the different variations, for the different API revisions of Metal and of OpenGL, and then push all of those into a single shader file from which we'll then load the correct ones. So the second one is actually the one that we're moving on to, and the load time building was the first solution. Also, because we pre-built the shaders, we needed a variant system. And this is kind of where there's a lot of discussion about, for instance, if you have Unreal Engine and you have a very complex shader, then you get building shader variations. That's pretty much it, pretty much the same thing here. That you have a number of variant flags that you can toggle on and off, and then we're building all the permutations of these flags. Alternatively, we're also using specialization constants. So we realized that this is a problem building all these variations because it could be minutes, it could even be tens of minutes if you have a very complex shader. So the alternative is to minimize the amount of variants and use specialization constants for runtime specialization. Metal and Vulkan both have native implementations for this, but on OpenGL we again emulate this feature. But it's a compromise between runtime, load time performance and build time performance that we need to balance on. So looking into the future, now that THOR is in active use within the company, we can focus on building stuff on top of it. So a couple of examples that I wanted to mention here. First of all, a render graph. So the idea of the render graph is that you can split your rendering work into these smaller tasks that have inputs and outputs. And this basically forms a dark acyclic graph. And we can then determine the execution order of these tasks and synchronize them based on their inputs and outputs. And then schedule these tasks on a predefined set of worker threads. So this is also why it's really important to have THOR be able to do multi-threading, because now we can actually have render pass tasks as well that are operating on any of these queues. We're also building a new material system. So now finally, because we have the SPIRV and the SPIRV cross conversion step there, we can also access reflection information relatively easily. And we can determine which uniform values are exposed by the shader and which texture bindings we can have there. And we can automatically generate a material template from that. Also, loading time optimizations were kind of mentioned there. that the shader build pipeline of THOR allows us to like pre-build our shaders and really minimize the amount of time it takes to actually create the shaders at load time and the associated render pipelines and stuff. And of course, because the API is extendable, we can leverage the improvements in recent like Metal and Vulkan revisions also over time, and like depending on if games want to use that, and they can check if those are available, then they can start using those features if it really adds to the gameplay there. So a couple words about what we actually learned in the process here. So first of all, one very important topic in my mind at least, which is sometimes like overlooked nowadays, is energy efficiency. So basically the capacity of batteries of these devices and the ability to dissipate heat is relatively limited. So these devices, like mobile devices, have a huge amount of power, but they heat up pretty fast. So you basically need to minimize your energy consumption to avoid burning through a battery and also generating excessive heat, which basically overheats the device and throttles its performance. So you end up having a really bad performance if you don't take this into account. And since rendering is on a hot path, we need to take this into account specifically in this case and pay extra attention to it. So a couple of examples. First of all, I would recommend using linear memory access patterns whenever possible. Many of you probably will know this already, but when you're accessing an individual byte in memory, you're actually accessing a full cache line that contains that byte. So if you have, say, 64 bytes scattered around in memory, you'll actually be accessing 64 cache lines if those individual bytes are in different cache lines. So you'll be reading in typically like 64 times 64 memory, 64 times 64 bytes memory, and you'll be doing round trips in your main memory, which is really, really slow. But if you would have all these bytes close to each other, you would only read a single cache line, and you will be able to access it from that. So that's like a rough idea of why linear access is important in many cases. And specifically mobile devices, bandwidth is what actually consumes energy and generates heat. So the devices are also optimized to minimize bandwidth usage. And that's something you need to pay attention to. Also, favor using multiple cores instead of maxing out a single one. So basically, you're able to run at a lower clock rate. And also because modern mobile devices tend to be heterogeneous in their core setups. So they might have like 3 different levels of CPUs, where the lowest of the hierarchy is basically a really low power core. And if you can run your game mostly on that low power core, then that's good because you're consuming a lot less energy. Also, there is this very traditional saying of premature optimization is the root of all evil. And that's, I think, taken pretty much out of context back in the days. And it was referring more to the fact of doing micro optimization, like really detailed optimizations of like how to actually machine code level optimizations. And it doesn't really refer to algorithmic optimizations. So it always makes sense to still write sensible code from the get-go and think about your algorithms. Do they actually make sense, or are you doing something stupid on there? Are you just going through memory all the time, like the same elements of memory all the time, when you could have just done that all in one pass and stuff like that? So it's something to keep in mind on there. And one thing I forgot to mention, in a lot of cases, when you're thinking about, okay, I'm going to do this, and then for production, well, I'm going to optimize it away. You know, we can fix it later on. But the reality is that, especially if you're budget bound, like you have a tight budget, either time or money, you will probably not find the time to actually fix it later on. So that's why it's good to like have the initial version at least be okay, so that you could go live with that. Then one thing to note is that devices don't often work as expected, especially on Android. Many devices either have like buggy drivers or even hardware. The situation isn't as bad as I had like personally expected it to be when starting to work on THOR and actually getting it production ready. But we do occasionally run into these really weird situations where something feels wonky, and then we need to, dig into why it is so on like a specific device or a specific device set. So a couple of interesting examples for those who are interested. For instance, there's this interesting case in like some, I don't recall exactly which devices there were like some HTC devices, if I recall correctly. The GLSL compiler didn't really like nested code blocks. So you had like a function that had a nested code block, and for some reason that wasn't executed at all. And it doesn't really matter if you have a conditional clause in there or not. The only fix is to actually remove the whole nesting. And for some reason, the compiler seems to skip this whole block. For one reason or another, I don't know, probably it made some shortcuts there. But anyways, so that was an interesting one. And I actually ran into that when testing Clash of Clans, and the 3D elements were too dark. And looking into that, turns out that it wasn't doing sRGB conversion on the output color. And then that led me to this issue. Actually, in the same game, with the same characters, there was also the issue that on some devices, the characters were all gray, like everything was grayscale. And turns out that the reason was that I was storing the color value in the output, in the fragment output, and then reading it back again for doing some further color calculations. And the specifications actually state that you shouldn't do this, but it's very easy to do, and nothing complains you about doing that. So that's something that needs to be taken into account, that you should always process the color first and then just output it. And then one very interesting case was using structures to define uniform compounds. So you had like a structure where you had uniforms in there. And on some devices, these uniforms, even if that's like totally normal in GLSL, you should be able to do that. But on some devices, when setting the uniform values, different uniforms actually got the wrong data. So had like some matrix actually had like in one column it had a color, and the color had that same matrix column and stuff like that. So they got like totally mangled. And this was a tricky one to solve because it ended up making everything black. And then at some point, like a little red triangle popped up somewhere, and that was like a signal. It's actually rendering something, but what? And then you had to start digging. A couple of words about our culture now. So our culture is basically, the idea is that it's about empowering people to do their best work. And there's basically no red tape. So if you really need to do something, you can just go ahead and do it. Of course, it's your responsibility to make sure that you take everything into account, that you talk to the right people who are affected by your changes and stuff that you do, and that you actually care about the product, care about the teams that you're working with. But you can take the initiative, and you don't need to go through a lot of bureaucracy to get stuff done. And people take responsibility of the work that they do, which is really great. Like, you can, if you're talking about like with someone about some feature that they might be working on, and they say that, I'm going to do that, then you can expect that that person will actually pull the bandwagon. And if something goes wrong, then those people who have been working on that, you can count on them that they're going to be like jumping on the issue, and they're going to be either helping you fix it or they're going to fix it themselves. And this basically allowed me to directly work with the game teams and make big decisions on what THOR would actually look like and how it would work with these different games, and do it relatively fast so that I wouldn't have to like go ask 10 different people, is this okay, and do like plans and all that, get approvals for everything. It was very, very agile and versatile. But it's of course not all roses. Sometimes, we do things that we haven't asked the right people, and we make mistakes. But the benefits basically outweigh the downsides here. And of course, it's not really about like, you can make mistakes. It's totally fine. And everyone makes mistakes. The thing is, what do you do after that? Do you take responsibility for actually fixing it or making sure that it gets somehow fixed? That's what I think like responsibility really is. So to conclude, we built THOR for a need. So we always build technology for a need. Like, well, there are some cases maybe that some stuff has been made just because it's fun, but like mostly it's because we really need something. And in this case, we needed to work around the issue that Apple will be deprecating OpenGL-ES, and also around the issue that we're going to have like 2 APIs, we might have 3 APIs, and also it's getting more and more complicated to manage all that. So that's why we started working on THOR. We had to proceed really carefully because we were basically rebuilding the core of our rendering for every single of our games. And it's a tricky thing to do. But we couldn't have done that with our amazing QA, so a big hand to them again on that. Couldn't praise them enough. Also, finally, THOR is designed to serve our existing players so that we don't lose players because of it, while at the same time providing like higher quality visuals for our up-and-coming games and also for our existing games to improve their looks. And if you have any questions related on this, like related to this, you can come to talk to me after this or ask now in the QA section, or if you want to just DM me in Twitter, and I'll also be happy to ask those or answer those questions. That's it. Thank you very much.
Thank you, Timo. And I can see that you have some loot boxes in the corner,
yes.
So maybe that will motivate people to ask questions.
So I would say like the first 3 people like who ask questions can get the big boxes there, like 1 for each, of course. And then what is like left, you can come and pick up there if you want to have like there's a goblin statue, and those are like bigger. I think it was like barbarian statues, those. But yeah, if you have any questions, I'll be happy to answer.
I'll bring the mic.
Hi.
Hi.
I wonder how you just get the games to work. Just like I didn't, listen everything, but I wonder why you just choose THOR.
So was the question that like, why don't we use like? Could you repeat the question again?
Mä voin kertoa sulle tässä.
Yeah. Okay.
Miksi käytätte THORia?
So the question is, why do we use THOR? Well, it's. I did mention there that like we didn't before, and it was ending up with a lot of different issues. So we started working on that because like our life was difficult, and we basically just like had to do that. Yeah, I know. Hopefully that you can also, like, if you want to have like a look at the presentation slides later on, or come talk to me directly after this, and I can give you some more details on that. But pretty much because like we had to do something, and the status quo back in the days wasn't really enough, and so we needed to start working on THOR and get our games working on that. Did you get your statue? Cool.
Thank you.
No problem.
Thank you.
No problem. Next one?
Hi. Thanks for the presentation. You said that Brawl Stars was the first game Supercell has made that uses actual 3D graphics instead of 2D sprites. Was moving Brawl Stars to THOR unique compared to the other games, and were there additional problems with 3D?
Boom Beach has like 3D elements as well, but Brawl was like probably the first game that really kind of showcases 3D, and it's actually an interesting solution in that it's kind of this merger of like 2D rendering and 3D rendering, where actually some of these characters, they're actually rendered as billboards and then pasted on the screen in a way. So in some cases, you notice this when your characters are like crossing each other, and then the other one like pops in. So that's because they're billboards. Like some of the stuff there is rendered in like directly into the frame buffer as 3D elements, but some of them, partially because of the outlines that we want to render on those characters, are rendered through like sprites onto the screen. But basically, like, yeah, Boom Beach. In Boom Beach, it's not as obvious that it's 3D. It looks a lot like Clash, which nowadays still has, like, Clash also has some 3D elements, like the hero characters, they're 3D. But Brawl is probably the first game that actually like, made it first great citizen, or first. Yeah, probably get the point. Okay.
Hello. A question about shader compiling. So you said you're compiling them to SPUR-V, but doesn't the driver do that for you? Or was that for multi-platform or multi-API support?
Yeah, basically it's pretty much for that. So SPUR-V is actually an intermediate format anyways. So the driver, when you're compiling, like OpenGL has some extensions for using SPUR-V directly, but mostly it's for Vulkan. But the driver basically, or the compiler, there's still a compiler. It takes the SPUR-V and then generates, based on that, the actual bytecode for the GPU. So it's an intermediate language in itself, but it's optimized so that you can generate that hardware code much more easily than you would from like GLSL. So it's kind of an intermediate step in a way. It's not a perfect solution in that it's actually, as an intermediate format, it's not perfect because it has, there's like a long blog post series about like individual issues that it has for being used as an intermediate format. But for most cases, it still works pretty fine. So we do that basically because there was already a system for converting SPUR-V into like MSL and GLSL, or back into GLSL, or DirectX HLSL or whatever. So that was like a handy way for us to get all of this like platform-independent shader building working. Any other questions?
So you mentioned that people take responsibility for implementing features and then fixing their mistakes, but what happens when you notice that people are making the same kind of a mistake over and over again?
It's usually about communication. like, then we notice that the information isn't flowing. And a good place for that is to make sure that, or a good way to alleviate that is to make sure that we have opportunities for people to talk about those things. Like, for instance, we have these kinds of focus groups within the company for like sharing information about rendering, for instance. And also, like, if there is, like, for instance, in this case, like you're writing your shaders and you're making the same mistakes all the time, then it makes sense to document that and in these kind of focus groups or other meetups to make sure that people know about that. And well, then it's mostly up to them to actually make sure that they use that resource and try to fix the issues. But of course, like, nothing is perfect, and that's still going to happen. But all we can do is just make sure that we minimize those situations. Any other questions?
So about the driver quality between GL and Vulkan, I mean, if I understand correctly, the premise is that there's with Vulkan and with Mantle and Metal, there's less work in the driver and exposes more functionality, so that there's and GL drivers do more work. Has there been any improvement on Android and I guess on desktop if on the driver side?
Yes, there's a question like that. The Vulkan drivers are much simpler, and like if basically it's not an easy equation. The Vulkan drivers actually have only been becoming stable since like 1.1 or something like that, when attention has been put into like testing and providing like a really good like baseline for what actually how it needs to work. And sure, it's simpler, but in like GL drivers, in a lot of cases, the complexity comes from like these game-specific things that are done on that, like stacks on top of stacks of stuff that is built in the drivers. But it doesn't mean that the Vulkan drivers are super easy to develop. There's still complexity in them, but of course, like less so than GLSL. But yeah, the mistakes are more than on the client developer side, that it's easier to like screw things up in your Vulkan code compared to GLSL. So the complexity has kind of moved to a bit to a different place, and it's the challenges remain.
Maybe one more. Was someone? Any? Oh, there. Yeah.
So, what would you say are the benefits of using THOR over Unity or Unreal Engine, and have you considered switching to Unity or Unreal Engine?
Well, I'm not going to be talking too much about that because it's an inflammable topic. But the thing about THOR is that it is just a rendering core. It is not like Titan even isn't Unity. Like they are two different things, really. So THOR for us is that because we're like committed to developing Titan, we're committed to the code base that we have. It runs like billion-dollar games, and we know it really well. It works. So we're committed to that, and THOR was like just a natural step for us to make sure that the platform is ready for the years to come.
Great. Thanks so much for all the questions, and Timo, great presentation. Thanks again.
Thanks.
By the way, we have a few goblins left, so
first
no
come,
questions
first serve.
needed. Yeah. Run.
Yeah.